Welcome to bilingual e-lectures for diploma students, sponsored by Directorate of Technical Education, Tamil Nadu. This lecture discusses about the C programming. This part of the lectures we deal with algorithm and flowchart. In the previous two lectures we have discussed about the computer and the program development cycle. Programming requires problem analysis and design. So, in the previous lecture we seen the program development cycle, which involved defining the problem, analyzing the problem and designing and representing the algorithms. Now, we are going to discuss about what is the meaning of algorithm. This is the main method for representing the logic of the solution. After understanding the problem, the programmer or the system analyst should devise an algorithm which is suitable for the computer. So, the algorithm means an ordered sequence of well defined and effective operations that produce a result, and it should terminate in a finite amount of time. Algorithms are restricted to computer, not only restricted for the computer world. In a day to day life, we apply some logic or some method to solve the problem. In this way, for a numerical problem, we use algorithms for the computer. So, for example, if you are going to find an area of a circle, first we analyze the problem, the method of finding the area and finding the circumference. We should know the formula, we should know the area of this. To calculate the area, we need the radius. So, these are the requirements we get from the analysis. So, the algorithm should represent the solution to the machine. So, in this we write down the steps to solve the problem. In this case, for finding the area and circumference of a circle, read the radius of the circle r. Then find the area and circumference of the circle using the formula area equal to 3.14, this is a pi value into r. So, pi r squared. Then circumference equal to 2 pi r. These are the formula required for finding the area and circumference. So, we calculate these two values, and the next step should be to display the result. So, it is print. So, such a sequence of steps for the given problem is called an algorithm. The properties of algorithm, how the algorithm should be? It should be a simple and precise. An algorithm must always have one clear understood starting point and one or more clearly understood ending points. That means, we start at one point, there may be different ending point according to the conditions. An algorithm must be precise, it must be effective. That should be actually the algorithm should be effective in the sense it should be a short and efficient algorithm. It should complete in a very short time, it should take very less time. So, the algorithm must have a fixed and finite number of instructions. The execution of an algorithm must always terminate. That means, it should complete in a finite number of times, it should not be an indefinite process. The algorithms are of different types. According to the problem and the method of solution, these algorithms can be classified into recursive or iterative. A recursive algorithm is the one that calls itself repeatedly until certain condition matches. This is called a recursive algorithm. It is a method common to functional programming. Next, interactive algorithms use repetitive constructs like loops. The another types of algorithms are called logical or procedural algorithms. In this category, the algorithm may be viewed as controlled logical deduction. A logic component expresses the axioms which may be used in the computation, and a control component determines the way in which the deduction is applied to the axioms. So, we use a logic to solve the problem. Generally, programs are executed in a sequential manner in a simple computer. So, algorithms are usually discussed with the assumption that the computer execute one instruction of an algorithm at a time. That means, each instruction is executed one by one. This leads to a serial algorithm. Parallel algorithms take advantage of computer architecture to process several instructions at a time. They divide the problem into sub problems and pass them to several processes. This algorithm, parallel algorithms, can be implemented on parallel computers, where the problem can be divided into different sub modules which can be analyzed or executed parallelly. Next, deterministic and non-deterministic type of algorithms. This category, actually the algorithm solve the problem with a predefined process, whereas a non-deterministic algorithm must perform guesses of best solution at each step through the use of heuristics. The algorithms are steps to solve the problem. These steps can be pictorially represented using different charts. One type of representation of algorithm is a flow chart. So, the flow chart is a diagrammatic or pictorial representation of algorithmic steps. So, they are graphical representation of sequence of instructions or operations carried out to perform certain tasks. In this flow chart, we use symbols for different actions or steps of an algorithm. Those symbols we will see in the next slide. These geometric shapes indicate different operations, and these symbols connected by the flow lines, which indicate the order of execution on various activities. So, these are some symbols used for representing algorithms. The first one is a oval shape. It indicates start or end of the flow chart. The initial process, the starting process and the ending steps are indicated with this symbol. Then the rectangle indicates a process or a calculation. The parallelogram indicates input or output actions. The fourth one is a diamond shape, which indicates the decisions or conditions. This is a connector symbol which connects a flow chart, one segment of a flow chart to another. We can mark some symbols on this connector circle symbol. The flow lines, arrows, they are used to link various boxes or various shapes of the flow chart together to form the flow chart and indicate the direction of flow. They indicate the path of the flow of data or the steps. So, the advantages of flow charts. Flow charts are language independent. For any language we can use these flow charts, they are language independent. So, it only explains the algorithm or the steps. They provide a very brief overview of the system or the problem logic. Flow charts express clearly the logic of a given procedure. It enhances the understanding of procedures. Flow charts make debugging easier. Flow charts are used as documentation aid and programming aid. Disadvantages of flow charts are they are quite costly, that means they need some more time to develop, so and difficult to use and manage. For very large programming, the development of flow charts are complex task. They occupy more space. The preparation of flow chart is time consuming. Actually, they occupy more space than pseudocode. That means, the instructions can be written in a simple language which is called a pseudocode. We will see it later. This is a sample flow chart where we read two values A and B. Actually, this start symbol indicates the beginning of the problem logic, and we read data A, then read data B and calculate sum. So, sum equal to A plus B and print. Here the read and print are represented using parallelograms, and calculation is represented as with a rectangular shape. This is the end of the flow chart. This is a very simple logic to add two numbers. Here it is given in steps. Read or get the first number in A. A is one data variable, another data is B. We read B, add A and B and keep the result in sum. Now, print the sum value, which is the result. So, this way the logic can be diagrammatically represented. We can easily understand the problem solution. This is another example. Here we read income and cost, that is expense. Right. Now, start with the problem, read the data income and the expense or cost. Here this diamond symbol represents a decision which is called a condition. We decide whether income is greater than or equal to cost. If it is greater, then we take a path and calculate the profit. Here S represents the condition is true. If it is true, we get a profit, we calculate profit from income minus cost and we go to print. So, print the profit, then stop. Suppose if the condition fails, that is it is no. Is it true? Is income is greater than or equal to cost? No. Then we come to calculate loss. It is also a process. Then we print the loss. So, all the calculations like input, all the steps like input and print are given in a parallelogram, and calculations like assignment are given in rectangular boxes. Here there is a flow chart to find the number whether it is odd or even. To check the given number is odd or even, we have to find the remainder of the number when it is divided by 2. So, first we read the data and we get the remainder of number by 2. If the remainder is 0, it is an even number, otherwise it is an odd number. So, that is represented here. Start, read n, r, let r be the remainder, r equal to n percentage 2. Here percentage is a remainder operation, it gives the remainder when n is divided by 2. If the remainder is 1 or if the remainder is 0, it is an even number. So, when you divide a number by 2, when you divide the even number by 2, it will result in 0. So, if the remainder is 0, then it is even number. If it is not 0, it is an odd number. So, here the decision box check the value of the remainder, it takes 2 decisions. The arrow indicates the flow. After the decision, it goes to either printing odd or even. This is a two-way selection method. So, then it comes to the end. This is a flow chart for finding the largest of given 3 numbers. So, you are given 3 values. Our task is to find the largest of the given 3 numbers. First we compare the first 2 values, then from the largest among the 2 number is compared with another number. So, here the 3 values are read in A, B and C. This is a input function. Then we compare whether A is greater than B, that means the first comparison check A and B. From this, if the A value is greater, again A is compared with the third value. Actually, the first value is compared with A is compared with B and C. If A is greater than B, we immediately check A is greater than C. If A is greater than both B and C, we will decide A is the largest. Suppose if A is not greater than C, C is the largest number. Since A is already greater than B, now it is less than or equal to C. Here we assume all the 3 values are not equal. So, A is greater than C is true, means it will print A. If it is not greater, means C is greater. So, it will print C. Right. If the first condition itself it fails, that means A is not greater. If it is false, if the condition here, if it is false, A is not greater, that means B is greater. So, we compare B with C. If B is again greater, B will be the largest, otherwise C is the greatest. In this flow chart, we have used the symbols, start symbol, this is a input symbol, these are the output symbols. So, these are parallelograms, and there are 3 decision boxes for conditions, and it is finally it is a stop. So, the another one is the connector symbol is used when a flow continues to another page or another part of the flow chart. We continue with the connector symbol. So, after this it will continue from here. The circle is a connector symbol. In this way we can extend our flow charts to many pages. So, another method of representing algorithms is pseudo codes. Pseudo codes are program like statements, but they are informal notations containing natural language text used to describe the functioning of a procedure or a program. So, pseudo codes are user prepared, unambiguous English language sentences that describe the procedures to solve a particular problem. Pseudo codes are alternative to flowcharts, and sometimes it depicts the logic of the solution in a more clear terms. Pseudo codes use mathematical symbols and numbers. For example, I write a step for the odd number, read n. So, we read the value of n, test n by comparing if n percentage 2 is 0, then n is even, otherwise n is odd. So, these type of instructions are called pseudo codes. So, we write the steps in English like sentences. These are not actually a program. This can be translated into a particular language statements. In the next lectures, we will use a particular language to convert these types of algorithmic representations like flow charts or pseudo codes into real language programs. In this series of lectures, we are going to use a C language as our programming language for writing programs, and we will see the features and the statements of C language in the next lectures. Thank you.